some finger math. So we're going to continue on with the unit circle today. I'm going to talk extra loud today because I have no idea how well my microphone works. So unit circle, we know a unit circle has a radius of 1. That's kind of the base circle that we're dealing with here, right? We know that when we have a Cartesian plane, our XY axis, and a circle all the way around it, that along the circumference of that circle, we can figure out coordinates of points. And that's what we're going to do today. And we're going to use our fingers or the hand trick to tell us these points, okay? So when you are asked to find the coordinate of a point on a unit circle when given an angle, use your left hand with its palm facing up. Okay, so you're always going to use your left hand, palm facing up, because you want your thumb to be on the left and you want to be able to bend your fingers. Now, you'll see on the right hand there that your hand has 5 fingers, obviously, and each finger represents an angle. So your thumb represents 90, your index finger 60, your middle finger 45, your ring finger 30, and your pinky represents an angle of 0. You have to memorize these. This is not on your formula sheet, okay? The way I remember it is we know that 45 degrees is like the middle of an angle, right? If you think of a quadrant, 45 is the middle, it's the middle finger. So you should always remember 45, okay? And then on the right, they pop up by 30 or 60 to 90. So that's a pop-up of 30. And on the right-hand side, it goes 30 to 0. So another increment down of 30. Okay? So you do have to memorize these, unfortunately. Now, if I give you an angle, like I give you the angle 60 degrees, and I want to know what's the coordinate on the circle that represents 60 degrees, this is what I use, okay? So I'm just going to go right down into an example, and it'll start to make a bit more sense, okay? But we have to do a bunch of stuff. As you see, we have to bend some fingers, we have to square root them, we have to put them over 2. It's quite complicated. Okay, so let's just go right into an example then. Determine the exact coordinates of a random point P on the unit circle with the angle given. Okay, so I want us to find the coordinates that represent 30 degrees. So you know me, I like to do a little drawing first just to see what we're looking at here. So here's my Cartesian plane. There's my circle. 30 degrees is about there, okay? So I want to know when this terminal arm of 30 degrees lands on the circumference, what are the XY coordinates of that point? Okay, we know this angle is 30 degrees. We were given that information. So we put our left hand with our palm facing up. There's my left hand, because the people in period 4 can't see my fingers, right? So I'm holding up my left hand. My angle is 30 degrees. If you look at the drawing above, 30 degrees is your ring finger. Yes? Put it down. Okay, now, how many fingers are still up on the left? 3. And how many fingers are still up on the right? 1. Those are the startings of your coordinates, okay? So if I'm looking for coordinates, this is what we do. The number of fingers up on the left goes on the left. The number of fingers up on the right goes on the right. Then, as per the little formula I gave you above, you have to square root each one of those numbers and put it over 2. And that is the starting of your coordinates. But now we've got to clean it up if we can and confirm our symbols. Okay? So, root 3 over 2, there is nothing we can simplify in root 3 over 2. Root of 1, well, let's not write square root of 1 because we know it's 1 and then over 2. That's the simplified coordinates. Should they both be positive? Yeah, because we're in quadrant 1, right? So quadrant 1, both x and y are positive. There's the coordinates of that point. Done. So that's how you use your hand to figure out what the coordinates of that point would be, the xy. Okay, let's do another one. I want us to do the same thing, but with 60. Okay, so again, I'll draw this. This is so not necessary. Okay, there's your unit circle. I am looking for 60-ish now. Okay, so I'm a little bit bigger. That's a 60-degree angle. I am looking for the XY coordinate of where my terminal arm lands on the circumference. Okay, so you're going to put your left hand up, thumb on the left. 60 is represented by your pointer finger or your index finger. Okay, that's this guy right here. You bend that one down. The number of fingers still up on the left is 1. The number of fingers still left up on the right is 3. And now you can put your hand down and start your coordinate work. Okay. So the number up on the left goes on the left. The number up on the right goes on the right. That's simple enough. You square root each one and you divide by 2. That never changes. That's the same every time. Square root each one, divide by 2. Clean up if you can. The root of 1 is just 1. And then root 3 over 2, you can't clean that up. We're still in quadrant 1. We're still positive. We're done. Okay? And that's how you find the coordinates. Let's do one more, a little bit of a weird one, because we're going to do 0. Okay? So 0 degrees means we literally have not moved. Now, I'm going to show this to you with finger math, and then I'm going to explain it to you with common sense. You wouldn't even need to use finger math here, okay? So there's our Cartesian plane. There's our circle. Here's my standard position. I always start along the x-axis, right? And if I haven't moved, my angle 0, I'm right there. Yeah? Okay. Now, finger math. There's my thumb, my index, yada, yada, yada. 0 degrees is your pinky. If you were to put down your pinky, you would have 4 up on the left and 0 up on the right. Okay? So now when you go to your coordinates, the number up on the left goes on the left. The number up on the right goes on the right. You square root each one and you divide by 2. Now, when you clean this up, what is the square root of 4 divided by 2? 1, right? What's root of 0 divided by 2? 0. Now, you use finger math. We use finger math to prove it. But obviously, this is the 0.10. Because if you look at our Cartesian plane, this is a radius. And we know the radius is 1 in a unit circle, yes? Okay, so this radius right here is my x distance, so that's why there's a 1 in the place of my x coordinate. And then have I moved up or down? No, so my y is 0. So that's the common sense approach. But you can always use finger math to confirm. Yes? So whenever you are on an axis, you guys, x, y, other x, other y, your point should always be a mixture of like 1 and 0 or 0 and 1, and then you figure out the negatives or positive. So you should never really have to rely on your pinky for that one. You know what I mean? You know what I mean? Yeah? Okay. Okay. Let's do the same deal, but with radians. Okay? So the point P is the point on the terminal arm, and it's on the unit circle. Determine the exact coordinates of this. So instead of giving you a degree, I give you the radian. Okay? And we just have to do one extra step of converting it to degrees. That's all. Because finger math, if you look at your finger math drawing, it's in degrees only. I don't give it to you in radians. So if it asks you for the coordinates and I give you radians, you have to convert to degrees first to be able to use your fingers. Yes? Okay. And these ones are going to get a little bit trickier too because we have bigger angles. So we're in other quadrants, meaning we got to watch our symbols. Okay? So 5 pi over 6. Now, if you remember from lesson 1, to convert from radians to degrees, you divide by 180 over pi. Your pi's cancel. then what I like to do is, well, I have a 180 up top and a 6 down low, and I know those can divide each other. 180 divided by 6 is 30. So really what I have left up top is just a 5 times now my 30. I have nothing left on the bottom. So I am dealing with the angle of 150 degrees. Does your finger math, does it have a finger that's 150? No. So we got to think a little bit harder here. So this is where I'm going to draw a Cartesian plane, because you know me. There's my Cartesian plane. There's my unit circle, and I'm going to draw 150 degrees. So 150 degrees, well, I'm not quite 180, right? I'm 30 degrees shy of 180. So we've already established that I don't have a finger that represents 150. So in this scenario, any guesses of what we use instead? Split it? No, because if I split 150, that's 75. 30 is remaining, so you want to use 30. 30 is the right answer. What is 30 though? Exactly. What is 30 in this case? Like, what do we call it? The reference angle. So when you have an angle in another quadrant, you guys, that's not on your fingers. You have to find the reference angle instead. Okay? So the reference angle here is 30 degrees. We are 30 degrees closest to our closest x-axis. So now we can proceed with finger math. And then to make sure it matches up with 150 degrees, we just watch our symbols, because we're in quadrant 2 now. Symbols change, right? Okay, so you're going to take your thumb, your index, yada, 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 yada. And because we are using 30 degrees, we are going to fold down our ring finger. I'll have 3 up on the left, 1 up on the right. So now you can start your coordinates. It's the square root of the left one over 2. It's the square root of the right one over 2. Now we're going to simplify those and add our symbols in. Root 3 over 2 cannot simplify, but because I am in quadrant 2, I know my x values are negative. So you have to write that in. Okay? And then root of 1 over 2 is just 1 over 2. We are in quadrant 2. Your y values are still positive. Don't touch that. And that's how you do a question with radians in a different quadrant. Okay, let's do another one of those. A couple more of those. All right. 7 pi over 4. Now you have to convert this to degrees. I showed you in the previous one how to convert it to degrees by multiplying by 180 over pi, yada, yada, yada. I just want to show you there are other ways. This is how I actually think of it. This is just 7 times 180, because we know pi is 180 when we're talking about degrees, right? So you can just do that as well. If we're trying to convert to degrees, just change the pi to degrees. So 7 times 180, and then divided by 4, you should get 315, sorry, 315. I said 45 because that's our reference angle. I got ahead of myself. So 315 degrees. We are in quadrant 4. This is optional. Okay, 315 degrees is about right there. Okay, 315. So that means our reference angle, we are 45 degrees shy of our closest x-axis. That's the finger we're going to use, is the 45. We use our reference angle now. Okay? So I'm not going to draw the hand this time. You guys figure it out. 45 degrees, whenever I think 45, I think middle. So I know I'm going to put down my middle finger, which is 2 and 2. Okay? 2 on the left, 2 on the right. So start your coordinates. It's a square root of the first one, 2 over 2, the square root of the second one, which is also 2 over 2. So your coordinates are the same. Can we simplify those? Can we take the root of 2? No. And that's why in the question it says exact. Find the exact value. Because if you were to actually find the square root of 2, you'd get decimals and everything. We don't want that. We just leave them as roots. Okay? But then what do I have to add in? Negative where? Both? X isn't negative in quadrant 4, right? So we're just going to write a negative on the Y value and we're cruising. You guys getting it? Last one. Oops. I like this one because it's 90 degrees. Pi is 180, right? So if you cut that in half, this is actually 90 degrees, which is on an axis. Yeah? Okay. So this is an example where you can use common sense again. You don't even have to use finger math. So 90 degrees is right here, right? So I am looking for that coordinate right there. We know because the unit circle has a radius of 1, in one of these scenarios, we're going to have a 0, 1, 1, 0 type thing. My x-axis, I have not moved. I've just gone straight up. So my x value is 0. My y value is positive 1. Done. So you do not have to use finger math with 0 or 90, the extremities, really. See what I mean? It's common sense for those guys. Can we move on to something else? Okay. We are going to now start incorporating sine, cos, and tan. So a little nugget of very valuable information. We are used to thinking of coordinates as x and y, right? Okay. Instead of thinking as coordinates of x and y for a while, we're going to think of our coordinates of sine and cos instead. So I didn't really talk about it, but on the front page, I wrote a little note, just so you guys have it in your notes, that x can actually be represented by cos and y can actually be represented by sine. Okay, x is cos, y is sine. And I'm going to show you how that's going to help us. Because in this first question here, I want us to figure out the tangent of certain degrees or certain degrees or points, okay? This formula is going to help us. Tan is actually equal to sine over cos. And I'm going to prove it to you, if you don't believe me, very quickly. Okay, Sir Coxertix, remember that guy? Okay, go away, that little symbol is saying we're trying to reconnect. I can't write. Okay, Sir Coxertix, sine is y over r, cos is x over r, tan is y over x. Yes? I am saying that tan is equal to sine over cos. So in other words, I'm saying that tan, which is y over x, is equal to sine, which is y over r, over cos, which is x over r. I'm saying that the left side and the right side of that are equal. And I'm right, because if I don't write the division like this, if I flip it and write the division like this, okay, that's the exact same thing. And then we know that when we actually divide, we can just flip that, find the reciprocal of that, and multiply. So this whole thing becomes y over x is equal to y over r times, I've flipped it, and then those just cancel out. And look at that, y over x equals y over x. So what? I just proved that tan, which is this guy, is equivalent to sine divided by cos, because when you cancel those r's out, you get y over x equals y over x. So if I ever ask you to find tan, it's the same as just dividing sine by cos. Okay, so here's what we're going to do. I want us to determine the tangent of 60 degrees. The only way that we're going to be able to find the tangent of 60 is if I can find the sine of 60 and the cos of 60 and divide those two, because that will give me tan. I know that if I can find the coordinates of 60 degrees, like the xy, like we were just practicing on the previous page, the number in the x value is cos and the number in the y value is sine. I divide the two and I have found tan. Okay, it sounds complicated. It's really not. Let's do an example. So 60 degrees, you need to find the X and Y value or the coordinate of 60 degrees. That's finger math, okay? Because we have a finger that's 60, right? So if you put down your 60 finger, which your hand's on the other page, who remembers? Which one is 60? Your index finger, okay? If you put down your index finger, which represents 60, you have 1 up on the left and 3 up on the right, but you square root each one and divide by 2, okay? Let's clean those up. So this is actually 1 over 2, root 3 over 2, 60 degrees is in quadrant 1. Don't touch the symbols. Okay, so like I said before, this is actually representative of cos, and this is actually representative of sine. Meaning, if you don't believe me, you take your calculator, and if you were to type in the cos of 1/2, like shift cos to find the angle, it would give you 60. If you were to type in the root 3 divided by 2, get a big ugly decimal, then shift sine that to get the angle, it gives you 60. Okay? That's why it works. So now to find tan, I have to divide. So tan of 60 is equal to the sine of 60 divided by cos of 60. But I know that the sine of 60 is root 3 over 2. And I know that cos of 60 is 1 over 2. So that would be the setup. Now, just to let you know, whenever you're doing questions like this, if you want, instead of writing it like a fraction this way, you can divide it this way instead. Sometimes that's easier for our brains to comprehend, is dividing it by 1/2 that way, which means I have root 3 over 2 times 2 over 1. I have found the reciprocal of the second fraction, and I've changed it to a multiplication problem, because when that happens, my 2's cancel, a 1 doesn't matter, so this all simplifies to the root of 3. Now, if you were to take your calculators, because you like verifying your answers, and you were to type in root 3, get a decimal, and shift tan that, you'll get 60. Okay, so you can always verify your work. Okay, now that we know how that works, let's do another one, because I'm going to show you one where the degree is 150. So if we're going to use finger math, we got to use the reference angle. I'm not going to draw it this time. I'm going to try to hold myself back from drawing the Cartesian plane. You should know by now that if you have a degree of 150, the reference angle is 30. That's got to just be something that's just in your brain. Okay? Reference angle is 30. Reference angle is 30. Okay, let's figure out our coordinates then. And we actually did this one on the previous page. Okay, so I'm not going to explain it too much in depth. Root 3 over 2, but I forced it to be negative because I know I'm in the x is negative area, right? Quadrant 2, but my y value is positive. So there's the coordinates for the reference angle of 30, but I added in the negative because I know it's actually 150. Okay, so now if I want to find the tan of 150, tan is equal to sine divided by cos. Sine is the second value, so you start with 1/2, and I'm going to divide it, and I'm going to write it this way, by the cos value, negative root 3 over 2, which is 1/2 times 2 over negative root 3. And FYI, your coordinates are always over 2, right? They're both always over 2. So when you flip and multiply, you should always be able to cross off the 2's. And then 1, that's negative 1 over root 3. You still have that negative down there. You're not done, because we don't ever leave roots in the denominator. So I'm going to times by root 3. And my final answer will be negative. 1 times root 3 is just root 3. Root 3 times root 3 is root 9, or it's just 3. Make sure you have that negative there. It didn't get crossed off. And if you want a little refresher of how to know, remember CAST from pre-calc 20? We are in this quadrant here. That's where 150 is. So that means only sign is positive. Yeah? So our final answer for tan should be a negative because only sign is positive in that quadrant. Okay, one last one like this, and then we're going to go on to a different type of example, and then we're done. Okay, we're going to do 315 degrees again. I chose these values because we already did the work on the previous page to find these coordinates, just to try to save time. Okay, so we established on the previous page that we cannot use 315 degrees. That's not one of our fingers. We find the reference angle, which we found to be 45. Once we use the 45-degree angle to find our coordinates, we put our middle finger down. Whenever you put the middle finger down, you know it's 2 and 2. Okay, root 2 over 2 and root 2 over 2. But what am I going to do? I'm going to put a negative in with my y value because we're in quadrant 4. Okay, so y's are negative in quadrant 4, x's stay positive. Okay, so I'm actually asking you to find the tangent. So the tan of 315 will be equal to sine goes first. So negative root 2 over 2 divided by your second, or your first one technically, root 2 over 2. Now, at this step here, when you write it out, if you want to immediately write it out with the reciprocal in like that, you can skip this division step. You know what I mean? You know what I mean? You know what I mean? Okay. Okay. So this is actually negative root 2 over 2 times 2 over root 2. And like I said before, your 2 should always cancel. Okie doke. So this becomes negative root 2 over root 2. I'm not going to rationalize my denominators here because I don't actually have to, because what's my answer? Negative 1. Those just divide each other off. So don't rationalize. Don't do extra work. It's divided by itself, right? Be good? Okay. And if you were to go on your calculator and punch in the tan of negative 1, what does it give you? Someone tell me. Punch in negative 1 and go shift tan. Ethan? Negative 45. Pardon me. I thought it was 315. Who remembers my rant in pre-calc 20? You do not punch in the negative. Remember? Because tan can be negative in 2 quadrants. Yes? Your calculator gets stressed out. It doesn't know what to do. It doesn't know which answer you want. So you never actually type in the negative. You just type in the 1. So do that for me. If you were to type in just 1 shift tan, what does it give you? Positive 45. It gives you the reference angle. So by punching in positives only, it always gives you the reference angle, which we know was 45. Yes? And then we can work backwards to get the 315. Do you guys remember that from pre-calc 20? Me losing my mind? Good. Okay. All righty. Last example of the day before our quiz tomorrow. Reminder, right? Okay. A point P on the unit circle is given below. So it's like I've done the finger work for you, and I have told you your X and Y. You got to tell me what was the angle. They're both negative, which means we are in quadrant 3. So your angle has to be between 180 and 270. Yeah? Okay. So this is how I think of it. There, I'm going to draw my fingers again. If I have a 1 and a root 3, right? That means I had 1 up on the left and 3 on the right, which means I must have had that guy down. Yeah? Okay, so that finger is what? You tell me, because you got to memorize. 60 degrees. Very good. But my answer is not 60 because I'm not silly. I know that I'm in quadrant 3. So I know that 60 is actually the reference angle. Okay, I'm going to draw it out. So I know I am in quadrant 3, and I know that because of my negatives. I didn't just pull that out from nowhere. I'm in quadrant 3, and I know my reference angle to the closest x-axis is 60 degrees. Okay, so if I draw my unit circle, that was a terrible drawing, whatever, all good. Okay, that's the point I'm talking about right there. So I have to now find what the total angle is. How do I find that? Well, I know I've traveled 180 and then I've traveled another 60 beyond. So my angle is 240, but this is where you have to pay attention to what the question asks. Look at the question. A point P is on the unit circle is given below. Find theta, so find your angle, but then I give you a domain. And what do you notice about your domain? What unit are we in? What world? Radians, and you just found the degree. Your work is correct, but you just have to convert that now to radians and make sure that that is inside your domain. It is, because 0 to 2 pi is 360. So as long as we're less than 360, we're good. Okay, but we just have to convert that. There are a couple of ways you can convert this, but the way I taught you on day 1 is you take your degree and you multiply that to get from degrees to radians. You multiply by 2 pi over 180. Okay. Now 240 and 180 can be reduced. You can cut out 60 from both of those. You can divide each of those by 60 or reduce by 60. That would be a 4, that would be a 3. So on top, I have a 4 pi. On the bottom, I have 3. And that's how you convert to radians. Done. And we've confirmed that that's within our domain. Let's do one last one, you guys, and we're home free. I wanted to end with this guy, one of our common sense ones. Okay? So you don't have to use fingers. Just draw this point. Okay. So 0 means I have not moved on my x-axis, but I've gone down -1. Well, what angle is that? No. 270, right? I have traveled from here all the way around and I've ended there. You might have said -90 because we can work backwards in this unit, right? But why wouldn't I choose -90? It's not in my domain. My domain said from 0 to 2 pi. -90 is negative, so don't even go there. It's pointless. My answer is 270 degrees. Okay? But I want that in radians. So same deal. You take your 270 degrees times that by pi over 180. I see that 270 and 180 can all be divided by 90. Eat that one by 3, whoops, and this one by 2. So clean that up and you have 3 pi over 2 is 270 in radians, and that's within your domain. We're happy, we're done, all good. Any questions? Yes. Yes, this is all on the quiz tomorrow. Now, I'm going to say this right now so period 5 can hear me too. Hi, period 5. For your quiz tomorrow, I've already made it. I've already photocopied it. Every single question on the quiz is identical to one of the examples we've done over the past 3 days. No surprises. The wording is the same. I just changed the numbers. That's it. Okay, so there's no surprises. So if you want to study for tomorrow, I would read over your first 3 lessons and examples very closely. If you understand all of those examples, you'll be good for the quiz because, like I said, no surprises. Okay? All right, let's stop this recording. Bye.